Hi everybody. In this video, we're going to look at points of intersection with parametric curves. We'll look at where the curve crosses the coordinate axes and where it crosses a straight line. We'll work through 3 questions, and if you want to work along with me, you can download this PDF from my website. I'll leave a link in the description below. So in example 1, we're told that a curve is given by the parametric equations x equals 2t plus 4 and y equals 3 minus 5t. Where t is an element of a subset of real numbers. For part A, we need to find where the curve intersects the y-axis, and we're calling this point A. So at A, if it crosses the y-axis, then we know the x value must be 0. So we'll set this equation to 0, and we'll find that value of t. Then we'll substitute that value of t into the equation for y to find the y value. So 0, setting this equation to 0, will be 2t plus 4. So 2t will equal negative 4, and t will equal negative 2. Now we can substitute this value for t into the equation for y. So y will equal 3 minus 5 lots of negative 2. This will give us y equals 13. So the curve will have a y-intercept of positive 13. For part B, we need to find the x-coordinates of the points of intersection of a parametric curve with this Cartesian curve. So the way we'll go about this is we'll create an equation involving t. We'll find that t value and then substitute it back into the x and the y. When the two curves intersect, this y is the same as this one, and this x is the same as this one. So all we need to do is to substitute this into the equation and x into the equation. So the equation in terms of t will be y will equal the x squared minus x over 2 minus a 22. We'll expand out this bracket, and we can factor out the 2 from this numerator and simplify it with this 1. So we'll have 3 minus 5t will be 2t plus 4 multiplied by itself, minus the t minus the 2. So I'll simplify this fraction and multiply that with negative, minus the 22. So 3 minus 5t will equal 4t squared plus the 16t plus the 16 minus the t minus the 24. We'll move these terms over to the right-hand side and simplify this quadratic. So we'll have 0 will be 4t squared plus 20t minus 11. And we can factorize this. So we've got 2t plus 11 and 2t minus 1. So t will equal negative 11 over 2, and t will equal 1/2. So you can see the parametric curve will intersect the Cartesian curve at 2 points. One where t is negative 11 over 2, and one where t is 1/2. So if we look at when t equals negative 11 over 2, we'll substitute this value of t back into the equation for x. So x will equal 2 lots of that t value plus 4. We'll simplify that and we get x equals negative 7. For the other t value, at t equals 1/2, x will equal 2 lots of that t plus 4. X will equal positive 5. So the parametric curve will intersect the Cartesian curve when x equals 5 and when x equals negative 7. Let's try another question. In example 2, we've been asked to find the points at which this straight line intersects the curve given by these parametric equations. Do you want to give this question a go? Think about this x being equal to this one, and this expression for y being equal to this one. You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So if we substitute x into here in terms of t, and we'll do the same for y, then we'll get an equation involving t. So for y, minus the x minus the 5 will equal 0. We can collect the constant terms together. So t minus 2 over t minus 6 will equal 0. Then we can create a quadratic and cancel out this denominator if we multiply everything by t. So t squared minus 2 minus 6t will equal 0. I'll rearrange this. T squared minus 6t minus 2 is 0. And then we can solve this quadratic on our calculators, and we get t is equal to 3 plus or minus root 11. What this tells you is that the parametric curve will intersect the straight line at 2 points. One where t equals 3 plus root 11, and the other where t equals 3 minus root 11. So to find the points of intersection, we'll substitute this value of t into our parametric equations. So x will equal 2 over 3 plus root 11. We can work this out and we get approximately 0.317. We'll do the same for y. We'll have 3 plus root 11 minus 1, and this is approximately 5.32. So one of our points of intersection will be 0.317 and 5.32. Okay? The second point of intersection, now we'll substitute this value of t into the parametric equations. So we'll have 2 over 3 minus root 11. This is approximately negative 6.32. And y equals 3 minus root 11 minus that 1, which is approximately negative 1.32. So the second point of intersection and negative 1.32. Okay? Let's try one more question. Okay, so in example 3, we're asked to find where the line x equals 1 intersects a curve with these parametric equations within the range for t of 0 to 2 pi. So do you want to give this question a go yourself? You can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So the first thing we need to do is to find what values of t will make x equal 1. So we substitute the 1 into this equation. We can divide both by 2, and then take the arc sine of both sides. So the arc sine of 1/2 will be equal to t, and this is pi over 6. Using our cast diagram, we can find the other solution. We've got sine is positive in the first quadrant, and in the second quadrant. So our two solutions will be pi over 6 and 5 pi over 6. So the curve will intersect the line at 2 points, at t equals pi over 6 and at t equals 5 pi over 6. We can substitute these values of t into the parametric equations to work out the coordinates. So when t equals pi over 6, we know x is 1, so y will be 5 cos of pi over 6. So y will equal 5 root 3 over 2. At 5 pi over 6, we'll substitute that into our equation for y, and we'll get y equals negative 5 root 3 over 2. So the points of intersection are 1 and 5 root 3 over 2, and 1 and negative 5 root 3 over 2. Well, thank you for watching. I hope you found that useful. If you want more practice on this topic, you can download the worksheet and view the online lesson from my website, mrmathematics.com. I'll leave a link in the description below.